The Invention of Numbers. How abstract symbols built our world. Introduction. Every transaction, every calculation, every measurement, every digital interaction, they all rely on something we often take for granted: numbers. These abstract symbols are the bedrock of civilization, yet they weren't always around. Welcome to History and Inventions, where we explore the innovations that shaped our world. Today, we're counting back through time to uncover the fascinating story of the invention of numbers, how humanity moved from simple tally marks to complex numerical systems, and how these abstract symbols fundamentally built our world. Chapter 1. The primitive urge to count from one to many. Prehistory. Before numbers, how did early humans quantify? They likely used a rudimentary sense of more or less, one or many. As societies began to form, and activities like hunting, gathering, and later trading became more complex, a need for precise counting emerged. Early methods were physical, matching one-to-one with fingers, toes, pebbles, notches on bones, or knots in ropes. The Ishango Bone, dating back over 20,000 years, shows complex tally marks, hinting at sophisticated counting practices even in the Stone Age. These were not abstract numbers, but rather tangible representations of quantities. Chapter 2. Early systems, tallies, tokens, and the birth of place value. Ancient civilizations. The agricultural revolution brought even greater demands for accounting, tracking livestock, managing grain stores, surveying land, and administering taxes. This spurred the development of more systematic counting. In Mesopotamia, clay tokens of various shapes were used to represent different quantities and goods, a precursor to written numbers. The Sumerians developed one of the earliest true numerical systems around 3000 BCE, based on a sexagesimal base 60 system, which influences our time: 60 seconds, 60 minutes, and angles 360 degrees. Even today, they used cuneiform marks to represent values, introducing an early form of place value where a symbol's position determined its magnitude. Ancient Egyptians developed a base 10 system with hieroglyphic symbols for powers of 10, used for monumental construction and complex calculations. Chapter 3. Greek philosophy, Roman pragmatism, diverse numerical paths. Classical eras. The ancient Greeks, while brilliant in geometry and abstract thought, didn't prioritize an efficient numerical system. For calculation, they often used letters of their alphabet to represent numbers, alphabetic numerals, which was cumbersome for arithmetic. Their true mathematical genius lay more in theoretical proofs and relationships. The Romans, on the other hand, their Roman numerals, IVXLCDM, were excellent for record keeping, carving into stone, and basic addition, subtraction. However, their lack of a zero and complex rules for multiplication and division made advanced calculations difficult. These systems showed how different cultures adapted numerical tools to their specific needs. Chapter 4. The game changer. Zero and the positional system. India and the Islamic Golden Age. The most revolutionary invention in the history of numbers came from India. Around the 5th century CE, Indian mathematicians developed a fully positional decimal system based in incorporating a crucial concept that was missing from earlier systems: zero. Zero, as both a placeholder and a number in its own right, transformed arithmetic. It allowed for incredibly efficient and concise representation of vast quantities and complex calculations. This system, with its 9 digits and zero, was later transmitted to the West through Arab scholars during the Islamic Golden Age, who refined and spread it. Mathematicians like Al-Khwarizmi 9th century wrote influential texts on the Indian numerals, which became known as Hindu-Arabic numerals in the West. Chapter 5. Global adoption and digital transformation. Medieval Europe to present. Despite initial resistance, the immense practical advantages of the Hindu-Arabic system eventually led to its widespread adoption in Europe, particularly by merchants and traders who needed efficient calculation. Figures like Fibonacci played a key role in its popularization in the 13th century. By the Renaissance, it was firmly established, paving the way for advancements in science, engineering, and commerce. The decimal point was later introduced, enabling precise representation of fractions. Today, this system is almost universally accepted. Moreover, the invention of numbers is foundational to the digital age. All computing, from complex algorithms to the simplest smartphone app, relies on the binary system O South and 1 South, a testament to the enduring power and versatility of abstract numerical concepts. Conclusion. From simple tally marks on a bone to the sophisticated algorithms powering our digital world, the invention of numbers is a testament to humanity's profound capacity for abstraction and problem solving. These invisible symbols are not just tools, they are the language of science, the bedrock of technology, and the very framework that allowed complex societies to flourish. They built our world, one abstract quantity at a time. What's one area of your life where you couldn't imagine functioning without numbers? Share your thoughts in the comments below. If this journey into the profound history of counting fascinated you, be sure to like this video, subscribe to History and Inventions at History Inventions, and hit that notification bell so you don't miss our next deep dive.